Hello everyone and welcome to this webcast titled Narrowband IoT, a cellular technology connecting the Internet of Things. My name is Manuel Blanco, I'm Solutions Planning Engineer for Keysight Technologies and will be your presenter. Today, we also have with us Pablo Loriz. Pablo is one of our expert R&D engineers with a focus on cellular technologies, and he's going to help us with a couple of demonstrations in the subject using the Keysight UXM wireless test set. Welcome, Pablo, and thanks. The topic for today is about how network operators are going to be able to make best use of their current infrastructure to enable a wider market capture of the fast-paced growing IoT applications and the role NB-IoT will play. During the meeting today, we will go over the technical fundamentals of this technology so that we can understand the major test challenges engineers will be facing to enable a faster rollout of real deployments and products. But before we start, cellular IoT is really gaining momentum, and NB-IoT is acknowledged as one of the most disruptive LPWA technologies, providing a very cost-effective connectivity to the existing cellular infrastructure. As shown in the slide, there are plenty of operators in all regions making investments around NB-IoT today, with multiple trials happening and critical mass deployments planned for the second half of this year. But why NB-IoT is gaining so much traction in the industry lately? What are the covered use cases of this technology? Let me try to explain. Machine-to-machine, or M2M, it's a business that has existed for several years and is already used in applications like agriculture, asset tracking, or smart energy as a few examples. And the key drivers why companies are investing on this technology is because with the use of these kind of machines, they can improve their operational efficiency, and it also helps develop new services thanks to the customer insights this can provide. But if we look more in detail about what all of these different applications require from a technical standpoint, it is clear that a single technology will not be able to cope with all of the requirements due to its wide spectrum. There are applications like a connected car or a virtual reality glasses that require very high data rates and low latency. While on the other side of the spectrum, applications like street lighting or smart metering just need to send a few bytes per day, but with a very large coverage and low power consumption. To support the further growth of the IoT, the wireless industry has developed new radio access technologies, often referred as low-power wide area networks, that can better cope with the characteristics and requirements of these devices and applications. And we can talk about one of these typical use cases, which can be smart metering. Along several years, smart metering companies have provided different solutions which are all about wirelessly connecting the water meters to a data center so that the readings could be collected in a more automated manner. And the way these water meters work is very simple. So the device is continuously measuring the water that it's consumed and creates small packages of data with basic information which are periodically sent to a hub, resulting in just a few bytes sent every few hours. However, one of the challenges here is that in most of the cases, it is not possible to feed with electricity, and as we all know, water and electricity are not very good friends. And therefore, they need to operate with just regular batteries. The way this is done today is by using technologies that have been specifically designed to meet these stringent requirements. But the problem is that these companies have to then deploy their own network infrastructure and make it secure, maintain it, which translates in a very high investment for this type of companies. Therefore, current solutions are normally based on proprietary technologies which require a large capex investment to deploy the infrastructure. Sometimes these are also soft standardized and cannot fulfill the range and power consumption requirements. And in most of the cases, The cellular network is used as a backhaul to get all of these devices connected to the cloud. Therefore, the solution proposed by cellular LPWA technologies is reusing the cellular infrastructure so that the devices can connect to the operator networks directly. And that would enable, the use of normally stronger standardized technologies, providing access to improve and national coverage, and with added value services like mobility, roaming, security, and authentication. But reality is that this is not happening today. And the question is, what is actually holding back operators to develop this new type of services? And the reason is that the cellular networks were designed for human communications, not for machine type communications. So for that reason, the 3GPP has been working on creating new enhancements in its standard so that these type of requirements are taken into account. And one of those technologies is narrowband IoT. This standard aims to address the current network limitations with support for a massive number of low throughput devices that are going to have a very low modem cost, below the $5 modules, with low power consumption that can go up to the 10 years of battery life, and an improved indoor and outdoor coverage. And all of that is presented as an upgrade to the existing RAN infrastructure. The standardization of narrowband IoT began back in 2014 with a 3GPP styling item and completed its first frozen version of the standard less than a year ago. In its first Release 13 version, NB-IoT was designed to address specific use cases featuring low mobility, infrequent small data transmission, and occasional over-the-air software upgrades, but with low complexity implementation as a primary requirement. NB-IoT continues to evolve, and in the ongoing development of the 3GPP Release 14, new NB-IoT enhancements are being included in order to expand the applications covered so far, like asset tracking, fleet management, or light wearable as a few examples.